In this part of the lesson, we're going to focus on measures of variation, which just refers to how spread out the data is about the mean. And remember, mean is one of our central tendency measures, the center part of our data. Now we're going to just see how consistent is our data. Is it spread out all over the place, or is it clustered close together and it's more consistent? And the three measures for variation is range, interquartile range, and mean absolute deviation. And actually, let's go ahead and fix this. It's not really Q1 minus Q3 because we're not going to get a negative value because we're talking about a distance. So let's swap that around. So the range is just subtracting your largest value and your smallest value. That's the range of the data set. Your interquartile range hones in on 50% of the data, and you saw that earlier in the previous lesson, part of the lesson, where you are subtracting the difference between Q3 and Q1, the length of your box in a box and whisker plot. And then we'll also talk about mean absolute value, mean absolute deviation, which is the sum of the distances between each data value and the mean. And then we divide that by the total number of values we have. So again, range, interquartile range, and mean absolute deviation, MAD, gives you a measurable value of how spread out the data is. Is it consistent or is it scattered? If our measure is small, then we can make predictions of future data because it's more consistent. So here are some words that also mean variation, measures of variation. Sometimes people say measures of variability, measures of dispersion, or measures of scatter. They all mean how spread out is the data or how clustered is it. So let's talk about the 5-stat summary. This is where we're going to get our values that create a box and whisker plot. So we have a minimum value, we have Q1, quartile 1, we have Q2, which is also the median, we have Q3, and we have our maximum value. So we're seeing how spread out are the values that are located near the center. So our 5-stat summary are these 5 values, and we're going to plot them to make a box and whisker. So quartiles, let's talk about quartiles for a moment. These are values, it's not a range, these are values that divide our set of data into 4 equal parts, and each part represents 25% of the data. So the first step is we must arrange our values in our data set from least to greatest, and then we find the middle number. And in this example, we have an even amount of data values, so we don't have one median. So the way that you calculate to get one median is you take the 2 center numbers and you average them together, and we have 42. So our median for this data set is 42. That is Q2. So that is the first thing that you do. Arrange your numbers, least to greatest, and find the middle number. And this divides our data into a lower half and then an upper half. Because the next thing we're going to do is find quartile 1. The way you find the first quartile is you find the middle number of the lower set. So we have from 18 to 40. This is the lower half. And again, we have an even amount of data values. So we must take the 2 middle values and average those together to get Q1, which is 29. Our Q3 is the middle number of our upper half. And again, we have 2 middle numbers. And we average those together to get 54. So Q3 is 54. And again, keep in mind, a quartile is a value. Okay, so we have 3 values, quartile 1, quartile 2, and quartile 3. And you can see that we have 25% of the data in each of these quartiles. So if you were asked what percent of the data values lies below 42, you would say 50%, okay, because that would be this section and this section. Or if you were asked what percent of the data is above 29, That would be 25%, 25, and 25. So you'd have 75%. So our range, like we said, is just subtracting the smallest from our largest value. Our interquartile range is finding the difference between Q3 and Q1. So if we look here from 29 to 54, this would be our interquartile range. And if we had any outliers, such as 18 or 62, I don't know if they are, but those values would not affect your median, and it also would not affect your IQR. So when you have an outlier, you definitely want to use the IQR just like you'd use the median for a measure of central tendency. So our IQR, we would subtract 54 minus 29, and that is going to give us 25. So our IQR is 25. So let's take a look and find our box and whisker that represents Jude science grades. Now, we're not focused on a measure of central tendency, a single number to represent the set of data. What we're looking for is how consistent was he with his science. So the first thing is we are going to arrange these again. We have 52, 78, 82, 82, 85, 88, 90, 93, 94, 96, and 98. So he had grades anywhere from 52 to 98. So that range is pretty large. So he's not very consistent. So 52 we already identified is an outlier. So we would definitely use the IQR. Our range for his science grade ranges has a spread of 46. So that is a huge range of grades. It's not very consistent. So we're going to find our median is 88. So this is Q2. So on our graph, on our number line, we find 82 and we put a dot. We're doing the 5-stat summary, Q2. Then we have Q1 is 82. Oh, excuse me. Q2 is 88, which is here. And here is our Q1, which is 82. And then our Q3 is 94, which is here. So this represents our box. So from here to here, that's your IQR, and then the median. And then the dots are your least value, your minimum number of 52, and the largest value is 98. And that's where the whiskers come in. So again, this portion is what we're going to use to represent the spread of the data. So his IQR is going to be 94 minus our 82, and that is a value of 12. So his IQR is 12. Now let's look at his math grades. Let's do the same thing. So we're going to rearrange these from least to greatest, 82, 88, 89, 90, 92, 93, 94, 295s, 96, and 98. So you can see he was more consistent with his math grades. They're not going to be as spread out as his science grades. So 1, 2, 3, 4, 5, 6. This is our Q2, our median. So 93. We're going to plot that point. And then the middle number of the lower half is 89. That's Q1. And then the upper half, the middle number is 95. So you can see, look, how smaller this box is compared to his science grades. Much more consistent, not near as spread out. Therefore, we could make better predictions about Jude's math grades than his science If I were to predict what he would make on his next math grade, I would say a low A maybe, but with science, it was scattered all about, so I'm not really sure. Then our whiskers, we had an 82. And then we had a 98 is the maximum score. So again, look at this box plot, and let's go ahead and do the IQR. And we have 95 minus 89, that's 6. So his IQR, the length of this box, is 6 compared to a 12 with science. So you can see that he was way more consistent with math. So let's record these and just compare. So the range of science was 46. So we had a range. Science was 46. The IQR was 12. The IQR of math was 6. And let's calculate. We have 98 minus 82. So the range is 16. We've not calculated math just yet, but you can see that his range in science and math, the range on math was much smaller, as well as the IQR. So again, more consistent with his math.